Mamy w pierwszym zadaniu the line with equation y equals 2x plus 7 intersects the y-axis at point A. What are the coordinates of A?
0, 7.
Yes. Because of that 7 here.
Yes.
Subcio. Dalej, write down a fraction equivalent to 1.875. Co by tu zrobić? 1875. Możemy na górze pisać wszystkie cyfry, które występują w liczbie, a na dole liczbę przez ile trzeba podzielić, żeby ten decimal point znalazł się w dobrym miejscu. W tym przypadku jest to przez 1000. No i teraz trzeba simplify, nie? Cancel down both. For example, we can divide both by 25. It's 75 at the top. And 40 at the bottom. We can cancel that further by 5. 75 by 5 is 15, and 40 by 5 is 8.
Yes.
And I think that's that.
Yes.
15 over 8. Możemy wyłączyć całości, czyli 1 whole and 7 eighths. No ale fraction, no to jednak 15 over 8. Dobra, dalej mamy solve 5x plus 11 equals 3x plus 19. No to co? Minus 3x minus 3x. I od razu w jednym kroku możemy zrobić minus 11. Czyli stąd będzie 5x minus 3x equals 19 minus 11. Czy to rozumiesz, co tu się stało?
Nie bardzo.
Chcemy solving the equation. You want on the left hand side to be everything with x in it. And on the right hand side, you want just numbers. And to move sides, we can subtract or add things that are, for example, on the right hand side, but there is an x with it. So we can do subtraction of that 3x, but for both sides, because it has to balance. Whatever you do to one side of the equation, you need to do the exact same thing on the other side of the equation. So if we subtract 3x from right-hand side, we need to subtract 3x on the left-hand side. That's why I wrote it on both sides. And look, that other x appeared here.
Yes.
And on the right-hand side, it cancels down. Yeah, it cancels just itself, right? In the same move, we can sort that 11 that is on the left-hand side, but it's just a number without an x in it. So let's move that 11 to right-hand side. To do this, let's subtract from left minus 11, yeah, to cancel that down, but we need to do exact same thing on the right side, minus 11. That's why it's there. And thanks to that, we have x's on the left and numbers on the right. And now we can simplify 5x minus 3x is 2x, and 19 minus 11 is 8, and both sides divide by 2, so x is 4.
Rozumiem.
Can put that there. And it's very important, the order of division at the very end. You need to divide by the number that is standing next to your variable. That may be x, that may be some other letter.
Yes. Yes.
But sometimes, especially with fractions, we cannot just do the other way around. Like if it was 10x equals 2, we need to divide by whatever is standing next to x. So divided by 10, divided by 10. And we need to do 2 divided by 10, not 10 divided by 2 because it's easier. No, unfortunately, it will be just a fraction.
Yeah.
Yeah, to taka tam dygresja. Dobra, x to 4. Dalej. Dalej mamy mapę. 1 to 5,000. And a scale is always in centimeters. 1 centimeter on the map is 5,000 centimeters in the real world, right? How many meters are represented by a length of 4.5 centimeter on the map? So from ratio, we can multiply that 5,000 by 4.5. So we would have 22,500 then.
Yes.
But it is in centimeters. And to go to meters, we need to divide that by 100.
Yes.
Because 100 meters is 1 meter. So 225 meters is an answer. Dalej mamy. The number of hedgehogs in England is expected to reduce by 4% each year. Assume there are now 1 million hedgehogs in England. Work out the expected number of hedgehogs in England after 5 years. You must show your working. Alright. To jest zadanie na compound interest. Tylko zamiast compound. Zamiast pieniędzy na lokacie mamy jeże. No i tak, w pierwszym roku to jest ten 1 million. W drugim roku to się zwiększy. So increase 4%. Czyli będzie razem 104% of 1 million. Czyli inaczej 1.04 times million. To będzie w drugim roku. W trzecim roku będzie znowu przyrost o 4% z drugiego roku. A drugi rok to było to 104 times million. So we have times another 104. Kolejny przyrost. Another increase. Another year. W czwartym roku znowu będzie ten przyrost o 4%. Another increase. Co nie?
Tak.
Czyli mamy tak. After 1 year. Tak, to co się tu dzieje, to jest już after. No to after 5 years, that would be 1 million times, oh, sorry, it's saying that it's expected to reduce, not increase. My bad.
Oh.
Czyli jeże są na wyginięciu. Dobra, reduce. A ile to jest reduce o 4% ze 100? Ile procent zostanie?
96.
Tak, 96%, czyli 0,96. Więc za każdym rokiem będziemy times 0,96. I to będzie to the power of the number of years 5. I to wpisujemy w kalkulator.
Mhm. 815 372.
No i zostawmy to jako integer, no bo liczba jeży, no to musi być integer, nie? To możemy tutaj dać, że to jest rounded. And this is our result.
Okay.
Another way to approach this, if you are not sure about the compound interest, you can try that. 1 million hedgehogs. After 1 year, it's 0.96 times 1 million, right? That reduce of 4%.
Yes.
And find the result of that. Then another after 2 years, get that result and times 0.96 to get another result. After 3 years, get that answer and then again times 0.96 to get result, and continue up to the 5 years. But this is exactly what we did with the power, as all you have here is multiplication, and we just put that multiplication in 1. You are multiplying by the same number over and over again. And because of that, we can compound this to put together in the power 5.
Rozumiem.
Extra. Dalej mamy, here is a cubit A. Cubit B is made from 2 of cubit A. Volume of A, ratio of volume of A to the volume of B is 1 to 2, which makes sense, right?
Yes,
The
yes,
volume.
yes.
Matthew says that the surface area, the ratio of the surface area of A to the surface area of B must be the same, must be 1 to 2, because B is made of 2 of A's. Is Matthew correct?
Yes.
No.
No?
He's not correct because the surface area, so what is outside,
Oh, surface area.
yeah, it's also that bottom part, which isn't a part of the surface of the B. It's there in the middle, but we do not treat that part in the middle as the surface of B. We are looking at only outside of it.
Yes.
And
So
that,
no.
yeah, and that bottom from A, which is hidden there, it's not a part of the surface. Give the reason. Bottom face of A is not part of B. Albo możesz też spróbować policzyć. Give side A being length A and the surface of A is. So if the side length is A, and then there is A as well because it's a square, everywhere is a square. So what's the surface, the total surface of A? What would that be? We have 6 faces, right?
Yeah.
Top, bottom, and 4 at the sides. So we have 6 faces, and with the length of A and the area of square is just A square. So this is our surface of A, being 6 faces of A square each. Now the surface of B. We have again A, the length of A, but how many faces we have here? We have top and bottom for sure, but how many we have on the sides? There is 1, 2, 3, 4, yeah, 8 in total, plus the 2 from top and bottom, 10. So we can try now to work out the ratio of surface of A to the surface of B, and we can put that as a fraction because the ratio and the division, that sign is a division, and the fraction line is a division as well. We do that to simplify the A square, and 6 and 10. We can cancel them down. What's the common factor? 2. Divide by 2, divide by 2, and then we have 3 over 5. So we have the ratio being 3 to 5, not 1 to 2. So that's the algebraic way of showing that the ratio of surfaces is not 1 to 2, but it's different. Jakieś pytania?
Chyba nie.
Seven A. Complete the table values for equation y equals x squared plus 2x. And we have values of x and y. And first we have x equals -2. And let's put that -2 into the formula for y. So instead of x, I'm writing -2 squared plus 2x, and I'm using brackets because of that negative sign. -2 to the power of 2 is how much?
4.
Yes. And then plus 2 times -2, plus and minus gives us -4. So the first result is 0 to put in there. And another x being 1. So y equals 1 squared plus 2 times 1 is 1 plus 2, so 3. That's at the end. And now we need to draw the graph. All right, so the first point, -3 and 3. -3 and 3 coordinates, so that will be here. Another one, -2, and it was 0, so here. -1, -1, so there. And then 0, 0, so there. And 1, 3. Okay, and now we need to put a line. Do you know that this is a quadratic function?
Yes. Yes.
Więc to będzie parabola. Tu przecina, tu jest taki lekki łuk, zawraca i do góry. O, prawie równo. Nie wychodzimy poza 1 i poza -3, to jest ważne. No i już. Powiedz, kiedy mogę dalej?
Można iść dalej.
Dobra. Jing has 2,450 pounds. She saves some and gives the rest to her 4 brothers. And the ratio of money saved to a given is 2 to 5. Okay, so we have 7 parts. She gives each of her 4 brothers the same amount. Does each brother receive more than 430? Show your work. All right. So how much money she gave up? How are we doing this? We have those 7 parts.
Mm-hmm.
This is saved. This is given. Those parts are equal, and the total of it is 2,750. So how much is 1 part?
Divide it by 7.
Yes. Which is 350. And this is that 1 part. So 5 parts given is that 350 times 5. So 1,750. So that's the money she gave to her brothers. So each brother must had that 1,750 divided by how much?
4.
4. Yes, 4 brothers. So, oops. 1,750 by 4. 437.5. Does each brother receive more than 430?
Yes.
Yes, this is more than 430. Lovely. Czy tutaj coś powtórzyć?
Nie trzeba.
Dalej. The pie chart shows information about people at a fair during 3 days. Thursday, Friday, Saturday. There were 132 more people on Friday than on Thursday. Work out the number of people on Saturday. Okay. So let's say that X is total number of people. At a fair. So on Friday, we would have, and because of this is a pie chart, and we can use those angles to make a part a fraction of everybody. Yeah, so the whole chart is showing X number of people, and that 1 part, oh, sorry, we should actually start from Thursday. On Thursday, we have 25 degrees out of 360 being the whole circle. So we can divide those to find the fraction of a chart times X number of people. And that 25 divided by 360 no, we can simplify this. We can cancel that down, but I'm not sure if we would need that common denominator later, so maybe let's skip that. On Friday, the fraction of our people would be 80 divided by 360 times total number of people at the fair. And on Saturday, that will be the remaining part of the chart, and that remaining part is 360 degrees minus 25 degrees from Thursday and 80 degrees from Friday. So 255. Times x. And now we should use that sentence saying there were 132 more people on Friday than on Thursday. So Friday is Thursday plus 132. This is what that sentence is saying. If we add 132 people to Thursday, we will get a Friday amount. Is that clear?
I think so.
Okay, so having that, we can then substitute what we found out being the Friday number of people. Friday number is 80 by 360x, and Thursday is 25 over 360x, and to that Thursday we need to add 132. Thanks to that, we have an equation that we need to solve for x. And here we can multiply everything by 360 to get rid of the fractions. So the first thing times 360 will be just the numerator, 80x. On the other side, that would be 25x plus, and then we need to multiply 132 times 360 is 47,520. Now we need to move that 25x. So I'm deducting from this side and from the other side. And thanks to that, here we would have only that number. There will be 0, it will cancel. And 80 minus 25 being 55x. So x itself would be this divided by 55 and that divided by 55. 47,520 divided by 55 is 864, and this is total number of people at the fair, 864. So going back to Saturday, our fraction being 255 over 360 times that x that we just found out, 864. Dobra, to na kalkulatorze 255 times 864 divided by 360. Można to jako 1. I będzie 612 people on Saturday.
Well. Było bardzo dużo na tylko 3 punkty.
Czy dalej?
Tak, można.
Dalej mamy. Use trigonometry to work out the value of x. Dobra. Mamy trójkąt. Tu jest nasze x, tu jest 46 centimeters, and this is the angle of 58. So we have what? We have opposite, there is a hypotenuse, and there is the adjacent. We have opposite and adjacent, and from Soka Toa, we would need the last one, Toa. So tangent of x is opposite divided by adjacent. So tangent, not x, but tangent of
58.
58, yeah, but instead of x, let's put alpha for indicating that angle, because x is a length of this side. So we don't want to use the exact letters for different things. Okay, so tangent 58 is being x divided by 46. Is tangent on the calculator? Yes, it is.
Yes.
Tan 58. So we can do tan 58 and then times 46 to get an x, right? There, to get rid of that fraction, we are multiplying by denominator, both sides. And thanks to that, the denominator will cancel with this 46 and it will leave us just x. So x is more or less 76.62 centimeters.
Yes.
Yes. Dobra. Next thing is Millie is estimating the value of this bit. She rounds each decimal number to one significant figure. Work out Millie's estimate. All right. If she is rounding to one significant figure, so that cube root to the power of 2 will be what number? What number would be underneath? If you round 8.34 to one significant figure, what would that be?
8.
8. And let's do another one as well.
1.
10.
Yes.
10. So there is 8 times 10. So it's 1 over. The cube root of 8 is
2.
Yeah. To the power of 2 is 4. Times 10 is 40. And that's it. Okay. In B, Millie says my estimate must be more than the exact value. Without working out the exact value, give a reason how she can know this. Estimate must be more than exact value. In both cases, she rounded down, right? To 8 and to 10. So in total, she is dividing by smaller number. Than exact. Can you see that?
Yes.
So the result is then bigger. Co nie? Jak dzielimy pizzę na mniejszą ilość ludzi, to dostajemy większe kawałki. Im więcej ludzi, tym mniejsze kawałki. Czyli the result is smaller.
Tak.
If we are dividing by smaller number, the result is bigger. I już. Biased spinner. Red and green. Ali Bennett Carey want to know the probability of spinning red on the biased spinner. It means that it's unfair spinner, right? They each spin it and count how many times it lands on red and divide by the total number of spins. Red divided by the total number of spins. Ali says, I spun red the most times. Ben says, I spun the spinner the most times. And Carey says, my relative frequency of red is 0.25. Who had the best estimate for the probability of spinning red?
Carey?
Carey, yes. Carey gave the exact number, about the exact value. So his estimate is the best. From other saying, we cannot say much, to be honest, right? So his estimate is the best. Dalej mamy Dev. Dev spins the spinner 80 times. He says, my relative frequency of red is 0.185. Give a reason why his relative frequency must be wrong. So the relative frequency would be that number of red by the total. So he's saying that the relative frequency is 0.185. And this is number of reds by the total of 80, yeah? Dev spins the spinner 80 times. Okay, and we need to find that red. To find that red, we need to get rid of this fraction on the right by multiplying by the denominator, both sides. Yeah, this is the equation. So red would be this. 0.185 times 80. And this is 14.8. Do you know what is wrong in here?
It's not a full number.
Exactly. Not a whole number. So Dev must be wrong. And another one, Elena, spins the spinner 125 times, and she's saying that the relative frequency is 0.32. Work out how many times the spinner landed on green. Oh, that's interesting. Okay, let's find the red. Should we find the red? Or yeah, we should find the red. Okay, how to find the red? Similar to the other one.
0.32 times 125?
Yes. Which is 40. Okay, so total being 125 minus 40 of red, that will be green. The rest of them, right? The remaining part. 85. And it makes sense because green is the bigger part of the spinner, so more times of green makes sense.
Yes.
Lovely. Then we have Charlie. Charlie is driving 293 miles home. He leaves at 9 a.m., travels the first 176 miles as an average speed being 48 miles per hour, and drives the rest of the way and the average speed of 65 miles per hour. Will be home by 2:30. Let's find out. Okay, so if the first part is 176, the other part will be the remaining. So 293 minus 176 which is 117 miles. Okay, speed is distance by time. Yeah, miles per hour. If you can't remember which is what, the formula is within that unit, miles per hour, where per is that fraction line. Miles is the unit of distance and hour is the unit of time, so speed is distance by time. Right. Let's try average speed is the total distance of total time. Average speed is the total of average speeds, being 48 plus 65. Let's see if that works. 113. Total distance is our mileage, 293, and the total time is unknown. Okay, so let's get rid of the fraction. Times total time, both sides. So 113 times total time is 293. So the total time is 293 divided by 113. Which is 2.59 hours. And I think it's not a good way of approaching this. No, we shouldn't be doing that this way. Okay, let's try. The result is wrong, that's why.
Okay.
Let's try this. Let's find the time for each of them. Again, average speed is total distance by total time. And that average speed, let's take the first part of the journey. 48 miles per hour, and that's 176 miles by the total time. Or maybe let's just do this as time. First part of the journey. Okay, so let's times both by t. Yeah, we need to rearrange the formula to make t as a subject. Time 176 by 48 is 3.67. And second part, let's do the same. Average speed 65 miles per hour is distance 117 by time. So 65 by times t time is 117. So the time is 117 divided by 65 is 1.8 hours. So together, the total time is 1.8 plus 367 is 5.47 hours. So we have 9 a.m. started plus 5. It's not a good way of showing this. 900 plus 547 hours. Will that be more or less than 230? What do you think? Without calculating first.
More.
You think it's more? No, it's not, because 47 is in decimal. This is decimal number. This is not 47 are not minutes. So it's less than 5.5 hours. And 230 is exact 5.5.
Oh.
Yeah. 0.47 out of 60 is around 28 minutes. And to get this, you can multiply 0.47 by 60 minutes in the hour. So yes, he will be home by 2:30.
Rozumiem.
So this was our distance, this was our average speed or just speed, and then time was unknown, a variable to find, and then find the total time by adding them and then change the decimal to minutes, or just realize that this is less than 5.5 hours. Okay?
Okay.
Lovely. Czy robimy dziś 1,5 godziny, bo mogę?
Można.
Dobra, to lecimy dalej. 14. Kiran paid income tax and national insurance on her annual salary. The income tax is 0% for the first £12,570 of her annual salary, and then there is a 20% of the rest. National insurance is 0% of the first £9,880 on her annual salary, and the rest is at 13.25% rate. Kiran paid 5,186 tax. How much national insurance did she pay? Okay, so that tax is 20% of the taxable amount. And that taxable amount is her total annual salary minus the tax-free amount being 12,570. It's called personal allowance, as far as I know. And that difference is then taxable amount, which is then multiplied by 20%. Okay, so we have 20%. What we don't have is 100%. 100% will be that taxable amount out of which we got that tax amount. But this is our x. This is an unknown value for now. How to find x? How to make 100 from 20? Multiply by 5. And at the other side, we need to do exactly the same thing. That's it. So our taxable amount will be 5,186 times 5. So 25,930. This is taxable amount. Now our total annual salary will be that taxable amount plus tax-free amount, 12,570, okay? So that's 38,500. So now to calculate the national insurance, we need to take total annual salary and we need to divide that amount that is free of national insurance. It's different to the taxable free amount. So it's then 9,880. We need to deduct that first. Living with 28,620. And now this amount times a percentage for national insurance being 13.25%. Can you calculate this for me, please?
3,792.15.
Yes, exactly. Pounds. Czy to jest w miarę jasne?
Tak.
Subcio. $15. 180 runners started a marathon. Some of the runners did not complete it. The histogram represents the times of the runners who did complete the marathon, and we have the frequency density on this X and time on that X. How many runners did not complete the marathon? Okay, to find out the number of runners for each of that rectangle, so number of runners, it's the area of that one block, so the frequency density times time. So the first block and that time is the range, right? It's the range between them. So the first block, there is a 20 minutes. And the frequency density is, that's 5, that's 75, that's 80. 0.8 or 80. Can you see that? That here?
Yes.
All right. So 0.8 times 20 is 16. So we had 16 runners in the first block. In the second block, we had, again, 20 minutes, but the frequency is 1.8, I believe. $36. In the third block, we had a range of 40, and the frequency density would be 1.2. If this is in between of 1 and 1.5, the middle is 1.25, and this is just below. So that must be 1.2. Times 40 is 48. For 1, 2, 3, 4th block, we have again a range of 40 minutes and the density is, so look, it's between half and 1, so in between there will be 0.75, and that's just below, so that's 0.7. 28, and in the last block we have a range of 60 minutes and a density 0.4. This is 5.5, and each one is 5, 0.05. So 2 together is 0.1. Okay, so 0.4 is there. Can you see that? Okay, 0.4 times 60, 24. Okay, let's add them together. 24, 16, 36, 48, and 28, being 152. So the histogram shows us 152 people, while 180 started a marathon, so the remaining part would be those who did not complete.
So 28.
Yes. In B, we have the table that shows information about the runners who did not complete the marathon. So for those 28 people, we have least distance 5 miles, greatest distance 23 miles, lower quartile being 11, median being 18, and interquartile range being 9. Draw a box plot to represent the information. All right. So where we have, okay, we have least distance being 5. So let's put a whisker there at 5. We have greatest distance being 23. So we have 20, 1, 2, 3, 4, and 5. So 23 will be there. And put a whisker there. So we have least and greatest lines. We have lower quartile being at 11. And I think that will be there. 10, 11, 12, 13, 14, 15. Yes. So that must be here. Lower quartile. Here. We have median at 18. So 15, 16, 17, 18 will be there. There is a median. And interquartile range being 9. And interquartile range is upper quartile minus lower quartile. So 9 is upper quartile minus lower quartile at 11. So that upper quartile should be at 20. There. Okay, we have all them lines. And a box is within quartiles. So here and there is a box, and the whiskers are just attached to the box. Something like that. There is 11, there is 18, there is 23. Next, we have right angle triangle. A, B, and C, and we know that A is 16 centimeters, and we have a ratio A to C being 4 to 5. I'm changing the ratio to the fraction because I can. And we know that A is 16. And this allows us to do the cross multiplication because those values are proportionate to each other. So it means that if we multiply on cross 4 times C, it must be equal to 16 times 5. So 4C is 80. So C is 20. And now from Pythagoras' theorem, A squared plus B squared plus C squared equals 6 squared. Sorry. Let's start with A squared. 16 squared plus B is unknown for now. B squared would be C 20 squared. So B squared is 20 squared is 400 minus, because that's 16 squared being 256, right? It was on the left, but we need it on the right, so we need to subtract this now. Do you agree? So that difference is 144, and we have beautiful square root being 12 being dB. Work out the area of triangle. Area of triangle is 1/2 times its base times its height. So here our base is 12 and our height with right angle triangle is just this side, A being 16. Half of 12 is 6 times 16, 96 centimeters squared.
Tak.
Perfect. Czy ten krzyż rozumiesz? Widziałaś to już kiedyś?
Tak, tak, widziałam.
Pięknie. On jest bardzo przydatny, bardzo. All right, 17, we need to solve. X plus 8 over 2 plus 9 minus x over 5 being 4. Okay, we see fractions, we don't like fractions, we need to get rid of them. Multiply everything by the common denominator being 10. So times 10 here, times 10 here, and times 10 here. What it does? Let's rewrite numerator. Let's put times 10 on top of it and divide it by 2 plus, and remember to use parentheses. X times 10 by 5 equals 40. So what that 10 is doing? We can then cancel down that 2 and that 10, leaving 5 and 1, and that 10 and that 5 be leaving 1 and 2. So now we don't have fractions because in denominators we have just ones. So now we have what? From the top, I will move that 5 at the beginning. X plus 8 plus 2, 9 by minus x equals 40. Multiply numbers through the bracket. 5x plus 40 plus 18 minus 2x. Very important. Plus 2 times minus 1x is minus 2x equals 40. this term and this term is the same. So we have 5 minus 2, 3x equals. If you see the exact same thing on the both sides, 40 there and 40 over there, it cancels. And we would need just that 18 on the right side. So let's do minus 18 there and minus 18 there. Minus 18. So x is minus 18 divided by whatever is standing next to x. Remember about the minus sign, 18 by 3 is 6, and that's it. Okay?
Tak.
Dalej. We have f of x being x squared plus 6x, and we have g of x being 2x plus 4. In A, we need to show that the f of g of x is 4x squared plus 28x plus 40. So we have like f of g of x is f of g of x, which is f of, let's put that g of x over there, 2x plus 4. And that means in x, in f of x, instead of x, this and that, we need to put the whole thing, 2x plus 4. So 2x plus 4, the first thing squared plus 6 times that thing, 2x plus 4. Czy to kumasz?
Troszkę, dawno to robiłam.
Mamy dwie funkcje, złożenie funkcji, no i ta, która jest druga, ma być w środku, tak? Czyli zamiast tego g od x to wpisujemy to, co mamy z zadania, wszystko. No i potem to wstawiamy do wzoru na f of x, tylko zamiast po prostu x mamy trochę więcej rzeczy. Więc używamy parentheses. No i teraz będziemy to simplify, nie?
Tak.
Dobra. 2x plus 4 times 2x plus 4, because it means the square, right? Plus 6 times 2, 12x, plus 6 times 4, 24. Okay. 2x times 2x, 4x squared. 2x times 4 is 8x, plus 8x there, plus 4 times 4, 16. And that other bit. Okay. 4x squared, we have 8x, 8x, and 12x. So we are looking for the similar terms. A very important thing, x squared and x are two different terms. So
yes,
we cannot put them together, but x's we can. 16 plus 12 is 28x. And then 16 plus 24 is 40, which is exact what they said. We showed that those two functions together will simplify to that form. Okay?
Tak.
And now in B, we need to solve that f of g of x is minus 5. Okay, so let's put that our finding, 4x squared plus 28x plus 40 should be equal to minus 5. Okay, let's move that -5 to left-hand side. So to get rid of that, we need to +5 on both. So 45, right? I am adding just 5, which is a number. It has no x's in it. So I am adding that to just a number. 40 and 5 is 45. On the right-hand side, we have 0. And we do that because it allows us to use quadratic formula to find x's. Do you recall quadratic formula?
Yes, but I can't remember it very well.
All right. So first we need to identify A, B, and C. And our x would be on the fraction. On the fraction, we will be dividing by 2a. On the top, there will be b, and then plus or minus, because we have two results. If the x is the second power, we are supposing that there will be two results, up to two results. It can be one result, it can be 0 results. If x squared is negative number, there will be no result. No root in real numbers. Or if x squared is 0, there will be one result, being just 0, which is a number still. And for example, x squared is 16, there will be two results, being +4 and -4. Okay? So that's why there is that plus and minus, because one will be most likely positive and the other one negative, but that depends. And then there is a huge square root. And in that square root, we will be having b squared minus 4 times a times c.
Tak, pamiętam.
Dobra. So b is 28. Excuse me, there is actually negative b in that formula. Negative 28 plus minus square root b squared. 28 times 28, 784, minus 4 times a being 4 and c being 45, 720, divided by 2a, and a is 4, so 8. Right, so we have negative 28 plus minus, and from that square root, the difference is 64 by 8. So x would be negative 28 plus, and that square root is 8, plus 8 by 8, or x will be negative 28 minus 8 by 8. Okay, so from the first one, minus 28 plus 8 is minus 20 over 8. And another one is minus 36 over 8. Oh, so in this case, we would have both results being negative numbers, which is fine, because sometimes those roots, when you have a graph of a quadratic function, the graph can be there, and those roots are in here, and both will be negative.
Oh.
The roots are the result of this fraction, of this equation being the formula for the quadratic formula equals 0, and equals 0 is that point. It is where the y is 0.
Yes.
And x is something. These are the roots. Okay, so let's put them as whole numbers. Minus 2.5 or minus 4.5. Yeah. And those are our two. The answer is both of them.
Okay.
Two integers have a difference of 6. The integers are multiplied together. 9 is then added. Prove that the result is always a square number. Two integers with difference of 6. So let's say one integer is x and another one is x plus 6. And thanks to that, the difference between them is 6 because the second one is just 6 bigger. The integers are multiplied together. So we have x times x plus 6. So this is that multiplication. 9 is then added, plus 9. And we should prove that this is a square number. Okay, so let's multiply the bracket. So we have x squared plus 6x plus 9. Okay. So we have three things, and we can split the middle one into two things, 3x and 3x. In total is 6x. So we are changing that to make it 4 things now. We have 4 terms. And now let's see if we have any common values in the first pair. Is there anything that we can factorize from x squared and 3x? That common thing will be just x to the power of 1.
Yes.
We can factorize this, leaving x from the first term, x squared divided by x is x, plus 3, because 3x divided by x is 3. And that's from the first pair, plus now another pair, 3x plus 9. The common factor will be 3. And again, we are dividing 3x by 3 is leaving x, plus 9 by 3 is 3. And thanks to that, we have two common things now, being that bracket with x plus 3 here and there. So we can factorize this further, putting that x plus 3 at the beginning, and in another bracket there will be a remaining parts from both of them. So from the first part there will be an x, and from the second part there will be plus 3. All right? And this is that common thing. So we ended up with two identical things being multiplied. So we have x plus 3 squared which is a square number. Czyli taka sztuczka.
Aha, to dobrze.
Zazwyczaj właśnie trzeba dobrze napisać to, co jest w zdaniu. Potem trzeba napisać tą resztę całą. Tak, czyli two integers with the difference of 6, to znaczy, że jeden jest o 6 większy od drugiego. Potem napisać to multiplication and adding 9 at the end. Then we need to multiply through the bracket. Then we need to make 4 terms, and it's the easiest, and in most cases it's just enough to take that middle term and divide by 2, and it should appear with 2 common things to factorize. All right?
Tak.
Sunil thinks that E and D are linked by the equation E equals 36 over D. The graph shows the values of D and E for D between 2 and 6. Okay. Choose one point on the graph and state if Sunil's equation is correct for that point. Okay, so let's find some point. Maybe this one for 2. If D is 2, E is 15. 1, 2, 3, 4, 5. 1, 2, 3. 18. Okay? And now let's substitute to our equation. E, 18, should be 36 divided by D being 2. Yeah, 18 is 18. Left equals right. The equation is correct. And that's it.
Aha, dobrze.
Or we can say true next to that equation. If it wasn't true, if we had different values, then the equation wouldn't be correct. In B, we have stated that G is directly proportional to the square root of H. G is directly proportional to the square root of H. In other words, G equals some number K times the square root of H. With direct proportion, we have that factor here that we need to find. Going order. So the ratio G to H is 3 to 2 when H is 16. Okay, so let's change that H to 16. Okay, so how to make 16 out of 2? We need to times 8. So we need to times 8 on the other side as well. So 3 times 8, G will be 24.
Yes.
Okay. So let's now substitute the 24 to the equation for proportion, to this one. So G24 is some k and the square root of h, that was 16. Square root of 16 is 4, so we have k times 4. 4k is 24. So k is 24 by 4, which is 6. So our proportion is G equals 6 square root of h. And now work out G to h when h is 100. G will be then 6 times square root of 100. So 6 times 10, which is 60. G is 60. So our ratio G to h would be 60 to the 100, and we need to cancel that down to simplify it. So we can divide by 10. 6 to 10, and then divide further by 2, which is 3 to 5. And that's our ratio.
Aha, spoko.
Ciekawa jestem, czy dałoby się to zrobić szybciej. To jest aż za 4 marki, więc to wszystko pewnie warto pisać, ale spróbujmy, jeżeli G to H było 3 do 2, kiedy tam to było 16, a my chcemy sprawdzić, co będzie dla H, jak będzie 100, no to czy da się tutaj to razy 50 i to razy 50? No nie. Nie wychodzi to samo, więc nie na skróty. Potrzebny nam jest ten współczynnik proporcjonalności, that scale factor. O, to jest scale factor.
Dobrze.
Dobra. A solid shape is made from centimeter cubes. The front elevation and the side elevation of the shape are shown. Work out the maximum possible number of cubes and the minimal possible number of cubes in the shape. Front and side. Front. So I think that shape may be something like that. Widzisz to?
Tak.
Dobra, ale druga sytuacja jest taka, kiedy ten front to jest tylko ściana. Tylko ściana i ten boczek to też jest tylko taka ścianka. O. Widzisz, na grubość jednej kostki. Czyli to na górze to będzie maximum possible, a to na dole to będzie minimum possible.
Aha, tak.
No dobra. Co my tu mamy? 9 na 12. Tu jest 9, tu jest 5, tu jest 7. No to w takim razie tu musi być 2, żeby razem było 9 na wysokość. 7 plus ten kawałek, tu 2. I tu jest 8. Dobra. Myślę, że trzeba to podzielić, żeby to się dało ładnie. Czyli tutaj możemy chyba zrobić 2 kawałki. Number of cubes in the shape. To będzie volume. Volume side A times side B times side C. O, tu jest 5, to tu jest 3. OK. Najpierw sobie weźmy ten tutaj. Ten kawałek. To będzie 12 times 9 times 5. Length, width and height. A ten drugi kawałek tam z tyłu to będzie 3 times 7. 3 times 7 times 12. That long will be the same, times 12. And that together is 12 times 9 times 5, 540, plus 3 times 7 times 12, 252, which is 792. And that's maximum number of the cubes within the shape. Now the minimum. How to approach this? Then I think we need 3 parts. That first block is this one. And this block is 9 height, 12 length, and the third is 1 there, because our wall is just 1 cube long or width times 1. Second part will be that bit, and that bit have 5 there and 9 there. 5 times 9, and again times 1, because here is just 1. And the last bit will be, it was 3, there was 7, and then 1 again. 3 times 7 times 1. Okay, 9 times 12, 108. 5 times 9, 45. And 3 times 7, 21. to get the 174. What? Something is not right. Too much. Somewhere is... Tam, gdzie one się spotykają, tutaj, trzeba zabrać jedną z nich, może tą, stąd. Tu jest 1 cube na 1 cube. Tutaj jest ten punkt styczności.
Tak.
I policzyłyśmy go 2 razy. Trzeba go skądś zabrać, może stąd. Zamiast 12 dajmy 11. Bo ten 1 centymetr będzie policzony w tym żółtym.
Dobrze.
Ok? I teraz mamy 99 plus 45 plus 21, 165, and that's minimum cubes. Ciekawe zadanie, co nie?
Tak.
Dalej?
Tak, można.
Dobra. 22nd. Shape A and shape B are shown on the grid. Może ja je skopiuję. Describe the single transformation that maps shape A to shape B. Żeby znaleźć to musimy połączyć corresponding points. Nie wiem, czy uda mi się to zrobić tak, jak chcę. Ale spróbujmy. Stąd tu. Stąd tu. O, i mamy punkt, tam gdzie się spotkają. O, 7 and 4. Co jeszcze potrzebujemy? Side length 1, 2, 3, 4 units, and this side is 2 units. So B to A is 2 to 4, which is 1 to 2. So this is our scale factor. We have scale factor, and we see that it's actually flipped. So that will be, it's flipped. So the scale factor is with negative sign, negative half. And the center point is 7 and 4. So that single transformation is an enlargement with scale factor minus 1/2 and center 7, 4. Czy tu jasne?
Tak.
Dobra. Twenty-three. A boat sails 35 kilometers north from A to B. From B, the boat sails to C, and then back to A. Show that the distance the boat sails from C to A is 79 kilometers to the nearest. Okay, maybe let's find other angles. If there is 80, then on the other side will be 100. And this is our unknown x. And we need to find that x. Now, which formula we should use?
Pythagoras? No.
No.
Sin?
Cosine.
Or cosine?
Cosine rule. Cosine rule is saying that x squared should be one side squared plus another side squared minus 2 times one side times second side times the cosine of the angle between them. Okay, so I think we can put that all in the calculator. Try that. So we are starting with the square root, and we should use parentheses. So if you click the square root, then click the parentheses and insert all of that, and end with parentheses and then equal sign.
$6,240.099208.
Nope.
No.
Try again. Square root, then parentheses, then all of that, and when you came to cosine, you should put that 100 in parentheses as well.
Yes.
So you will end with double parentheses at the end.
Of 78.9942985.
Yeah, 78.994 blah blah blah, and rounded to the nearest kilometer is 79 as requested. Okie doke. Now work out the bearing of A from C. Okay. Of A from C, so that will be this huge angle, a bearing from C. So we are starting here, we are finding north, and then we are finding the line to the A direction. Okay. what we know. Maybe we can find this angle. That 100 is again here. And all of that is a circle, 360. We have 100 there. If we could find this little angle within the triangle, we could then subtract from 360 to find that all. So what we need if we are missing an angle? Can we? Yeah, I think we can do the cosine rule again. But in this case, it would be, so the opposite, 35 squared is 65 squared plus that 79 that we just found squared minus 2 times the first one times the second one times cosine of that our missing angle alpha. I don't think we can work that in other way. Okay, so let's try that. 35 squared 1225 equals 65 squared plus 79 squared is 10,466 minus 2 times 65 times 79 is 10,270 times cosine of alpha. Okay, let's deduct this bit, both sides. 1225 minus 10,466 is negative 9,241 equals negative 10,270 cosine alpha. Now both sides divided by whatever is next to our unknown. So that will be equals divided by 10 to 70, which is O, not negative, but positive. 0.8998. Is cosine alpha. So alpha is cosine to the negative 1 of this value. Can you see that on your calculator? This
Yes.
This function, and use parentheses for just a precaution. Alpha is 25.866896. So we can say that alpha is close to 26 degrees. 26. And thanks to that, our bearing will be the whole circle 360 degrees minus that 100 that is known from you know, where we have two parallel lines and they are crossed by the third line. This angle and this angle is there. Here, there. So thanks to that we know that there is 100, there is another 100 there, and we found that 26. So from the whole circle there, we are deducting the green 100 and the yellow 26. And that's 234 degrees.